Hi, this is John. A little while ago I presented a little podcast on the effect of burning on the soil temperature compared to where the stove is left on the surface. And there are a few questions about what impact does this have on the soil and farming. So I thought I'd go a little bit deeper into this. So firstly, the soil physical properties are impacted by removal of surface residues by burning, because it exposes the soil to greater temperature fluctuation, erosion and water loss through runoff and evaporation, and loss of nutrients. I came across this place in Murewa recently where the grassland had been burnt on one side of it, the road, and unburnt on the other. And you can see the burnt area is very bare, whereas under the grass it's not too bad. There's actually a fair amount of litter on the surface, and the temperature is about 24.6 degrees C. You can see the litter is actually quite good in a way for this sort of environment. So the surface is well protected in this situation, but on the burnt area you can see it's very exposed and the temperature is a few degrees higher. So that shows how the burning affects the soil temperature and exposes the soil to the environment. When you look at the temperature profiles under burnt or unburnt areas, we see that in the early morning, around 7 o'clock in the morning, the temperatures of the air and the soil surface under burnt or stove is fairly similar. But as the day proceeds and the sun rises and the air temperature increases, so too does the soil temperature. But under the burnt stove area, the temperature increases quite rapidly and is the highest, reaching a peak of just over 40 degrees, whereas the temperature under the stover tracks pretty closely the air temperature up till about midday, and then increases slightly until about 3 o'clock where it reaches a peak. But that peak is still about 5 degrees less than the burnt area. As the sun starts to go down, the temperatures drop quite rapidly until they get close to the air temperature, and they'll remain close to the air temperature through the night. So there is a diurnal fluctuation in the temperature on the surface of the soil, and under burnt areas it's generally higher during the day than under stover. I came across another area in the Seke district where the soil had been burnt, and this was during midday, and again the temperature underneath the burnt stover grass was about 47 degrees C, and next to that there was an exposed area of cropland with very little stover on the surface, and here the temperature was also pretty high, about 46.5 degrees, so a little bit cooler than under the burnt area. And next to this was a grassland where there was a fairly good grass cover still standing, a fair amount of mulch the surface, but here even the temperature was quite high, 43.5 degrees, so a little bit cooler but still quite high. The ambient temperature at that moment was 29 degrees. Now admittedly this is end of September, so it's very hot and dry, but the differences are still quite significant, that under these exposed areas the temperatures on the soil surface are very high. So what impact does this have on microbial activity in the soil? Well, soil microbial activity depends basically on three things: organic matter as a food source, soil moisture, and the temperature. Bacteria are more resilient generally to high temperature than fungi, but both of them in a mesotrophic situation have an optimum temperature of 25 to 35 degrees C for growth and activity. In a water limiting environment like we have now at the end of September, early October, higher temperatures do not necessarily lead to higher decomposition of organic matter, simply because there's very little moisture available for those microbes to function properly. Now, when you do remove residues through burning, you obviously decrease the amount of biomass on the soil surface, and therefore you also are decreasing the organic matter supply for soil biota to feed on. And so with less organic matter there, you might expect that the soil microbial activity will be less, and that is true when there's a moisture limitation. But as soon as it becomes wet with rainfall or irrigation and the temperatures are still fairly high, there will be increased decomposition of the soil organic matter, because the only source of food for those soil microbes is the organic matter in the soil, because there's nothing from the above ground organic matter for them to feed on. So removing residues through burning or physical removal will rapidly decrease the organic matter content of your soil, because the microbes will consume the organic matter that is in the soil, and there'll be no replenishment from above ground biomass. Finally, let's consider how much nutrients are lost or made available when maize stover is burnt. Now, the ash content of maize when burnt is about 5%. So if you have let's say a 10-ton crop of maize and you burn it, the ash remaining will be about 500 kilograms per hectare. And of that 500 kilograms or 5% of ash that remains, the vast majority of that is silica, around 70%. There's a little bit of potash, carbon, calcium, phosphate and magnesium in that ash, but very small quantities. Most of the nitrogen and sulfur is lost during the burning. So you do lose a significant amount of nutrients, but there is obviously some that is returned to the soil. The most obvious thing though, of course, is that you are losing so much organic matter, and that is the biggest concern when stover is burnt, because the soil is exposed to rain, heat from radiation. Soil microbes have very little food on which to feed upon, except the organic matter that is in the soil, like the roots and decomposing organic matter that might be there. So overall, burning is a very negative practice or event, either in grassland or on cropland, because it impacts so greatly on the soil physical and microbial conditions in the soil. So thank you for watching. If you have any questions or comments, you are free to contact me. My email and phone numbers are there, and we appreciate your attention. Thanks and cheers.